What's up, guys? Today we're going to learn how to convert units, and let's get right into it. So dimensional analysis is basically just a fancy term for unit conversion. Now let's understand what is a unit and what the heck is a dimension. So a unit is just a value that represents the amount of some physical quantity, right? So if I have feet or centimeters or kilograms, well, really feet and centimeters are measuring the same thing, right? Like length or width. Kilograms is measuring mass, so they relate to some dimension. Now, what is a dimension? A dimension is basically just a physical thing that we see in everyday life, but it's a way to kind of quantify it, or not quantify it, but put it into words to kind of conceptualize it mathematically. So like, for example, length, right? If I have, I don't know, a cube, right? Then what I'm going to have is, well, we have this thing called length, right, or height, and then we have our width, and then we have our depth, right? So the height, the width, and the depth, those are all going to be kind of like dimensions, okay? Now, this is kind of reiterating what I said, but a dimension is just, again, that physical aspect of reality that we can actually measure. And a unit is the amount of that dimension that we can measure. So a unit is kind of a way, it's something that makes it relatable for us to understand how much of a specific dimension something is involved. Okay, so basically, guys, the fundamental concept of dimensional analysis is just this. We can treat units just like numbers, okay? Now, there is a little bit of how do I say this, rigorous philosophy to justify this because it's not as easy as that, but we're not going to go into that. Let's go ahead and do an example. So if I have 10 kilograms, right, the kilograms is going to give us the, the context for which the 10 is referring to. So if I just have 10, well, it doesn't really tell me much, but if I have 10 kilograms, then I know, okay, I know approximately how heavy that is, right? So again, units are giving that context, right? Now, anytime that we divide two of the same units, if let's say I had like a ratio 10 kilograms to 20 kilograms, well, my kilograms are going to cancel out just like any other variable would, right? So I'm going to have 1/2. Now, again, guys, this is what I mean by a dimensionless multiplicative factor. This has no dimension associated with it. So if I just say 1/2, I'm going to ask, well, 1/2 of what? And we don't know that, right? It's just going to be kind of like a multiplicative factor. Okay, so again, in short, units behave the same way that other variables such as x or y would in an algebraic system. All right, so the goal of dimensional analysis is to answer your homework, right? No, guys, I'm kidding. Basically, the goal of dimensional analysis is so that we can convert between units and get the desired answer, okay? So basically, the way that we're going to do this, there's really two steps, okay? So the first thing is we're going to set up a ratio of our units, right? So if I have like, maybe 1 kilometer corresponds to 1,000 meters, right? That's a ratio. So I can actually just flip this however I want, and then I can multiply it by other stuff so that our units are going to cancel out, except for the unit that we do care about. So let me give an example here, okay? So I have this house here, right? And it's 20 feet in length and 8 feet in width, and I want to know what is the area of the room in centimeters squared. So let's go ahead and, let's go ahead and calculate the area first. So area is just going to be length times width. So it's going to be 20 feet times 8 feet, and that is going to equal 160 feet squared. And again, we're going to square it because we can treat those units kind of like variables. Okay, so if I know that, well, I want the area of the room in centimeters squared, though. That's the thing. So what I'm going to have to do is let's go ahead and convert our units. So I know that, I have 160 feet squared, right? Okay, now the thing here is I know that in 1 foot, there are 12 inches. Okay, so this is a ratio. You could flip it, but in this case, I want to do it this way. That way, my feet are going to cancel. Here's the problem, guys. It's feet squared, not just feet. So what I'm going to do is I'm going to square this entire thing here. And because we have these parentheses, the square is going to go to both the 12 and the 1, okay? And, of course, to the units. All right, guys, now I know right here that there are 2.54 centimeters in 1 inch. So I'm going to say, all right, well, 1 inch, that corresponds to 2.54 centimeters. And now, guys, we're going to have to square this again because we want centimeters squared and we want our inches squared to cancel out. All right, guys, so now what's going to happen is our feet are going to cancel out, our inches are going to cancel out, and I'm going to be left with this, 160. Whoops. Let me go ahead and rewrite that. I'm going to be left with 160 multiplied by 12 squared, multiplied by 2.54 squared, with my final units of centimeters squared. Okay, guys, so if we go ahead and run that calculation, we will get that the area, so I'll say the area, is going to equal 148,645 centimeters squared, okay? So kind of a lot, but hopefully you see what I'm doing, right? You just manipulate these ratios, you multiply them together, and then, units cancel out. Okay, so in this second example, we're given the wavelength of blue light is 475 nanometers, and we want that in micrometers. So we need to convert nanometers to micrometers. So what I'm going to do first is I'm going to convert nanometers to meters. So I know that there are 1 times 10 to the 9th nanometers in 1 meter, and I know that there are, sorry, this should be a -6. There's 1 times 10 to the -6 meters in 1 micrometer. And guys, the way that you can figure out if this should be a positive or a negative exponent is just kind of think about it logically. So if I have that there's 1 times 10 to the 6th power meters in 1 micrometer, that doesn't make sense. There should be a very small amount of meters in a micrometer because a micrometer is small. So just something to think about. Okay, so now what's going to happen is my nanometers are going to cancel out, my meters are going to cancel out, and I'm going to be left with micrometers. So then you just multiply this, like just treat them like numbers. So what I'm going to end up with is 0.75 micrometers. Okay, guys, so that's the answer. Hopefully that made sense. Okay, so now I call this one a challenge problem, but it's actually pretty straightforward. So basically, we want to figure out how many miles does light travel in 1 microsecond if it's traveling 2.99 times 10 to the 8th meters per second. So we're basically going to do the same thing, except now we're going to need to convert 2 units, right? So let's go ahead and write it out. 2.99 times 8 meters per 1 second. So let's go ahead and convert meters to miles. So I know that there are 1,000 meters in 1 kilometer, and I know that there's 1.61 kilometers in 1 mile. Oops, 1 mile. So now my kilometers cancel and my meters cancel, and we have miles on the top, which is what I want. Now what I'm going to do is convert seconds to microseconds. So I know that in 1 second there's a lot of microseconds. In fact, there's 1 times 10 to the 6 microseconds. Okay, so now guys, whenever I multiply that out, my seconds are going to cancel, and now I'm left with miles per microsecond. So whenever I calculate that out, and actually, sorry, let me go and do that really quickly. So 2.99, let's see here, whoops, 2.99 times 10 to the 8th. And I'm going to multiply that by 1 over 1,000, and then multiply it by 1 over 1.61. And finally, multiply it by 1 over 1 times 10 to the 6th power. Okay, so what I'm going to get is I'm going to have that this equals 0.186 miles per 1 microsecond. Now, we want to figure out how far does it travel in 1 microsecond. So I'm just going to multiply this by 1 microsecond. And now, guys, my units are going to cancel. So my final answer is going to be that the distance is equal to 0.186 miles. So guys, that's pretty fast. That's like, what is that, about 1/5 of a mile? Just like that in 1 microsecond. So hopefully, guys, this concept of dimensional analysis and setting up your ratios to convert units and cancel out the units that you don't want, hopefully that makes a lot of sense. And if you have any questions, feel free to comment below. If you like and subscribe, it would greatly help me out. And I will see you in that next video.